In this video, we are going to discuss some problem solving for week 3 discussions. The first question is asking you to write a sum or the difference for this log expression. Now, we are given a single log. We want to expand it out to write that in the form of the sum or the difference between the log. Okay, so first thing you see that this is the log by 2 with the radical with the index of 4, and you know that we can first rewrite the radical as x to the 4 y 3 over x to the 5th power, and the radical of 4 means to the power of 1/4. And using the power rule, I know that the power rule of the log is telling me that I can bring the power to the front. That becomes the coefficient. So that's 1/4 log of 2, and then x4 y3 z to the 5th power. And then from here we can apply a lot of different things. The product rule on the top, right, and the division rule to the bottom. Okay, so you can treat this thing as a whole and this thing as a whole, right? So these are the logs between the two factor divisions of the two factor. So that becomes the subtraction. So 1/4, I can keep it outside. So let's take care of the log of base 2. So log base 2, whatever on the top, because this is the division, so you take whatever on the top. The division turn into the subtraction. Logs of base 2, and then z to the 5th power. Okay. Now, this again is the product, so I can turn the product into the sum. Okay. So between these two guys, I can have the logs base 2 x to the 4. The product becomes the sum. The logs base 2 of y to the 3rd power. Don't forget that we still have the 1/4 in the front, and then the logs base 2 z to the 5th power. And then the next step, we go ahead and we bring the power down to the front. Right, all the power we move to the front. So 1/4 still outside, 4 go down here, logs base 2 of x plus 3, logs base 2 of y minus 5, log base 2 of z. And then we're gonna make the distribution of 1/4 to each of the term inside. 1/4 multiplied by 4, that's become 1. So log 2x. 1/4 multiplied by 3, that's 3/4 log 2y. 1/4 multiplied with minus 5 over 4 log base 2 of z. And this is the sums or the differences between the log. And that is your final answer. So from a single log, I expand it out. Now the next question, question 2, you want to write a single log. Okay, so we are given a long expression, 2 log 3 of x plus 3 log 2 of y minus log 3 of z. You want to combine this into a single log. Now that means we do the backward, the reverse process comparing to the problem we just did on the first problem. Okay, so now we want to string them, we want to combine them together, not expanding out, but combine them together. So first thing is, I see number 2, I bring it up back to the power, right? Bring it up here. I want to combine them together. So log 3 x of, this is 3, okay, of 2 plus log 3 y of 3 minus log 3 of z. Now we see that this is the addition. We have the same logs by 3, the same log by 3, the additions. So we can combine that together with the log by 3, right? Log by 3. Addition means this should be the product between x squared and y3. Okay? Step by step. And then the last thing, this is the logs by 3. Logs by 3. Subtraction. So I can combine it one more time. Subtraction means the division between this, go to the top, and then z to the bottom. And this is a single log that you are looking for. Next question, number 3. You are asked to solve the following equation. Okay, this is the equation 2 to the 2x plus 2 to the x minus 12 equals 0. Okay, this is the exponential equation, and we have the exponent here, but number 12 here mess up everything, so we cannot just move the two exponents on the two sides and then trying to match the base together or take the area on both sides. In this case, it won't work because there's number 12 here. Now we do see that 2 to the 2x, I can rewrite that 2 to the x to the square, right? Because the square means 2 times x give me 2x back. Same thing. And I see that we have 2x here, 2x here. So maybe we can do something with 2x. Let's z to be 2x. Okay? Now anyway you see z, 2x, that's become z. So z squared. 2x is z, z squared. Plus 2x is now z, minus 12 equals 0. And from here, you can solve for z by factoring. By factoring. Z, give me z squared. I need to find the two numbers. When I multiply together, I get minus 12. When I add together, I get plus 1. So that should be plus 4 and minus 3. Minus 3 times 4 minus 12. 4 plus minus 3 give me plus 1. So using the zero factor properties, I can solve for z. Z plus 4 here equals 0. And equals 0. And then I can solve for z to be adding 3 on both sides. I get z equal 3. And then subtracting z on both sides, I get z to be minus 4. Now don't forget that this question is asking you for x to solve for x, not for z. Okay, so we have two cases here. The first case is when my z equal 3. When my z is equal 3, I have to solve for x, right? Then I know that z is 2 to the x power, but z now is 3, so 3 equal 2 to the x power. So I have to solve for x by taking the ln on both sides, ln of 2 to the x, because I'm solving for x. When I take the ln on both sides, I know that I can bring down the x, right, to the front, so that gives me ln of 3 equal 2 equal x, and then ln of 2. And then to solve for x, divide both sides by ln of 2. So x equal ln 3 divided by ln 2. Or because this is the division of the same logs, you can combine that together. That becomes ln of 3 half. And this is the x value for the case when z equal 3. Now the second case, when z equal minus 4. We know that we let z to be 2 to the x power. And z now is minus 4. That means minus 4 equal to to the x. Okay, and to solve for x again, we are taking ln on both sides, ln 2 to the x power. And because remember, the ln, the log base e of the function of x, the domain of the ln cannot be negative. The argument inside the ln cannot be negative. We get -4 here. That means it doesn't make sense. So this equation has no solution, or the value of z to be -4 cannot give you any value for x, and therefore the only solution in this case is x equal ln 3/2. Okay, next question. Again, solving the following log function. Sorry, no, the exponential 4 to the 1 minus 4x equal 3 to the x. Now they are not the same basis, right? So I go ahead and I take the ln on both sides. When I take the ln, I can bring the power to the front. Okay, and then I can bring the power x down, 3. Now let's make the distribution. We are solving for x, right? So let's make the distribution of ln inside here. ln 4 times 1, that's ln 4. ln 4 times minus 4x, that is minus 4 ln 4, and x equal x ln 3. You are solving for x, so let's move all the x together on one side. Let's move this to the right hand side. I have ln 4 equal x ln 3. We add this term on both sides, 4 ln 4 and then x, right? Now there's the x, there's the x, so I can factor that, right? I can factor that. 4 ln 4 equal ln 4. Now to solve for x, I need to divide both sides by this term, right? So dividing by ln 3 plus 4 ln 4, dividing by both sides, ln 3 plus 4 ln 4. Okay, so dividing by that, I get x equal ln 4 over ln 3 plus 4 ln 4. And then you can plug in the calculator to get you the decimal value. Okay, that is how you solve the problems for the exponential equation. The next one, I think number 6. Again, solving. This is the log equation. So solving the log of 3 of x equal minus log base 3 27. Okay. In order for you to solve the log equation, we have to make the logs to be the same thing on both sides. Okay. Now we see number 3. We can bring it to the power. The minus 1, I can bring it to the power as well, because I'm trying to make the log to be the same thing. So the logs base 3 of x to the third power. Minus 1 go to 27. Minus 1. Now you see that log by, sorry, okay, the logs by 3, they are the same, they are equal to each other. They are the same logs by 3. That means the argument here and here have to be the same. So x to the third power has to be equal to 27 to the minus 1, right? So x to the third power, you can bring the power down here, change it to positive, or 1 over 27. So now you know that x to the third power equal 1 over 27. 1 over 27. And then to solve for x, I take the cube root 1 over 27, which is 1 over 3, because 3 times 3 times 3 is 27. So this is the answer for this log. And you can check the solution. 1/3 go back to here. It's make the function to be defined, so that's okay. Anytime you are solving the log function, make sure to check the answer to make sure that the domain is correct, right? Because some answers make your domain to be negative or 0, which is not true, and that should not be the answer to your log equations. Okay, we have problem 7, the next one. Okay, this problem we are given ln of 3 equal a, and then ln of 11 equal b. ln is log of b, e. Now we are asked to write the logarithm in terms of a and b, and the function is here, log ln radical of 333. So you want to write this function, this expression, as the terms of a and b. So how do I do that? Okay, somehow I have to relate number 33 to number 3 and 11. I know that I can use the properties of the logs. So first thing is, I know that ln 33 radical 3 means the power of 1/3, right? And then using the power rule, I can bring it to the down to the front. So 1 over 3 ln of 33. I know that 33 is 3 times 11, right? And this is the product rule. So the product rule means that we change this into the sum. So ln of 3 at ln of 11. And we already know that ln of 3 is given at a, ln of 11 is given at b. So basically you finish the problem with the expression of a and b, or this is 1 over 3a plus 1 over 3b. So we wrote this expression as the sums or in terms of a and b, which is this guy here. Okay, the last question in this videos, we are given a field function here. So f of x equal ln of x, g of x equal e to the 7x, and h of x equal x squared. Now, part A, you are asked to find the composite function f of g of x. Okay, so f become the outside function f of g of x. Now g of x is given at e to the 7x, right? E to the 7x. E to the 7x. 7. Okay, because g of x is e to the 7x here. And now this is f of this thing. So we go back to the function f of x. F of x is ln of x, ln of x, but your x now become e to the 7x. E to the 7x. Okay, so we found that this is the composite function f g of x. Now, what about the domain? Remember the domain of any ln, any log function make sure that the domain, the argument here, inside the argument has to be bigger than 0. So you know that e of 7 to the x has to be bigger than 0. And you need to solve for x. Okay, you need to solve for x. Now, that's one more thing you can simplify here before we find a domain. Don't forget that ln is the log with base e. Right, ln is log by e, and we know that the base e, they are the same. They cancel out, right? So you no longer have the log. You can chop down the 7x. So to simplify this guy, you have to simplify that to 7x. So make sure to try to simplify this until you get 7x. Okay, so this is the final answer. And if that is the case, what is the domain f of g of x is equal to 7x? What is the domain? This is 7x is a linear function, and the domain for any linear function is minus infinity to up to infinity. Okay, so that is how you find the composite function and the domain. Now let's try the next one. The next part is asking you to find f composite of g of 7. So this is the composite function. F is outside, g is inside, but your x now is the actual value of 7. So now we need to find what is g of 7. Okay, we need to find what is g of 7. First, g of 7. So go back to function g. G of x is e to the 7x, so g of 7 is e to 7 times 7, because your x now becomes 7. So e of 7 times 7, which is e to the 49. So g of 7 is 49. Okay, so now we are looking for f of 49. We know that f of x is ln x, right? Given as ln x. So f of x is ln of x. So f of 49 is ln of x now is 49. So ln of 49. And that is your final answer. Okay, how about one more? The last one. F composite of h of e. Okay, so f is the outside function, h is the inside function, and the value is e. So first thing is I need to figure out what is h of e. Right? I know that the h function is x squared. H of x is x squared. So h of e is x, so e go to the place of x, e squared. Okay, so I have f h of e, which is e squared. And then now I need to find f of e to the square. F of x is this guy, so f of e squared, f of x is ln of x, so f of e squared is ln of e squared, because e squared now is the x. And we can simplify this. It's very simple. ln is a log base e of e squared. You see that we have the same base e, they cancel, right? They cancel the log. You can bring down number 2. The answer is 2. Okay, one more question for this video. One last question. Number 9. Actually, 2 more. Number 9. So solve the log by 3 x plus 2 minus log by 3 of x equal 1. Now the first thing is you need to see that this is a subtraction between the same logs with a base 3. So you can combine them as a log of base 3. Subtraction means the division between x plus 2 and the x. This is the division rule, equal to 1. And then from here, when you combine that into a single log, you know that we can apply the logs definition, right? 3 to the power of 1, 3 to the power of 1, 3 to the power of 1 equal to this thing. Okay, so that's telling me that let's move this to the left side just to make it easy. And then the 3 to the right hand side. I go ahead and I multiply by x on both sides. So multiply by x here. Sorry. Okay. So let's multiply the x here. Okay, something is wrong here. Okay. Multiply by x on both sides. X and x, they cancel out. You have x plus 2, right? Equal 3x. To solve for x, subtract x on both sides. I have 2x equal 2. To solve for x, divide both sides by 2. You have x equal 1. So 1 is the solution to this log equation. One last question. One last thing. Find the domain of the log space 10 of x minus 2, x minus 3, and x minus 5 square. Okay, so again, the domain of this one, you want the argument inside the logs to be bigger than 0. That means we want the argument inside here, this whole thing inside the log, the argument of the log, to be bigger than 0. Okay, so how do I solve for this inequality? I know that I have to set the numerator to be 0. Okay, so set the numerator to be 0 to find the limit, the boundaries to be 0. That gives me x equal 2 or x equal 3, right? Setting each of them equal to 0 and then solve for x. I also need to set the denominator x minus 5 square equal to 0. That tells me x equal minus 5 equals 0 or x equal 5. Okay, so we have 2, 3, and 5. So 2, 3, maybe 5 here, right? So we have the region. Divide this. Now you want this thing, x minus 2, x minus 2, x minus 3, and x minus 5 square to be bigger than 0. You are testing for this expression. Okay, so we have the 1, 2, 3, 4 regions. So before 2, let's pick a value, maybe 1. Okay, so x, let's pick x to be 1. 1 subtract 2 minus 1. Right? Let's make it this way. 1 subtract 2, that's minus 1, so that's minus. 1 subtract 3, minus 2, that's a minus. 1 subtract 5, that's a minus. A minus square give me the plus. Okay? So minus times minus become plus. Plus divide by plus, at the end you get a plus. A plus is something bigger than 0, so the answer yes. Between 2 and 3, let's pick 2.5. 2.5 minus 2, that is 0.5, so that's a plus. 2.5 minus 3, that is a minus, because that's minus 0.5. 2.5 minus 5, at the bottom, I don't care if it's a minus or plus. When you square, you always get a plus, so I don't need to even calculate what I get at the bottom. Okay, it's square, I get plus. Now, plus times minus on the top, give me minus. Minus over plus, give me a minus. Minus is not something bigger than 0, so the answer is no. Between 3 and 5, let's pick 4. 4 minus 2, that is a plus. 4 minus 3, that is the plus 1, so that's plus. At the bottom, it's always square, so it's always plus. Plus times plus is plus. Plus over plus is a plus. Plus is something bigger than 0. So the answer here, yes. And then to the right of 5, let's pick 6. 6 minus 2, that is plus. 6 minus 3, that also plus, and the bottom is always a plus. Plus plus divided by plus. At the end, you get plus. Plus is something bigger than 0. So the answer is yes. So we solve for the domain. The domain should be something less than 0, less than 2. So minus infinity up to 2. We do not have the equal sign, so I use the open parenthesis. Okay? And union stands for and, right? And then this area, 3 to 5. 3, 5. And then union with the rest. 5 go to infinity, all the way to the right. Okay. And that is the domain of this log expression. Okay, so that is the end for this video, and thanks for watching.